Welcome to the architecture of numbers, where we will decode the hidden structures of decimals, fractions, and square roots using continued fractions. Continued fractions reveal the unique structures of numbers. For example, pi has a massive 292 term, while the golden ratio is the simplest infinite pattern. The square root of 2 is periodic, and Euler's number shows an elegant escalating arithmetic progression. A continued fraction expresses any real number as a nested sequence. It consists of the integer part, the partial quotients, and the infinite nested fractional part, providing a precise structural representation. Continued fractions help categorize the mathematical landscape. Rational numbers have finite expansions, governed by the Euclidean algorithm. Quadratic irrationals, like square roots, have infinite periodic expansions via Lagrange's theorem. Transcendental numbers, such as pi and e, have infinite, non-periodic expansions. The algorithmic engine uses a four-step cycle: floor, subtract, reciprocal, and repeat. This process isolates the integer part, calculates the remainder, flips it, and feeds the new number back in, continuing until the fractional part is 0 or the desired accuracy is reached. The Euclidean connection shows that each division step produces one partial quotient, terminating when the greatest common divisor is found. The division staircase visually represents how the quotient becomes the integer part, and the remainder flips to form the next level of the nested fraction. Truncating a continued fraction creates a convergent. These convergents, such as 17/12 for the square root of 2, are the best rational approximations. Each sequential term exponentially collapses the margin of error. The staircase of pi shows why 355/113 is a famous approximation. The massive 292 term makes adding the next fraction change the total value by an infinitesimally small amount, effectively stopping the sequence at a high level of accuracy. Continued fractions form a universal language of approximation. They are the underlying structural reality of numbers, physically proving Lagrange's theorem, and serving as a key to bridge the gap between irrational reality and rational utility through algorithms and approximations. The MiniWebtool Continued Fraction Calculator offers a flexible input engine for decimals, fractions, or square roots. You can control the precision by setting the maximum terms and instantly generate the standard notation, visual output, and Euclidean step breakdowns. Enter the sandbox and test the mathematical limits yourself. Watch the emergence of the 292 anomaly for pi, see the golden ratio's slow converging staircase, or observe a massive 16-step period for the square root of 94. Access the calculator at miniwebtool.com.